This topic is on intercepts. So if you look at the box at the top, it says the x-intercept or intercepts are the points where the graph intersects the x-axis. So if you look at the little sketch over here on the right, you will see that here is the x-intercept. It's where the graph of this line intersects that x-axis. And it says to find the x-intercept, we let y equal 0 and we solve for x. The y-intercept or intercepts are the points where the graph intersects the y-axis. To find the y-intercepts, we let x equal 0 and we solve for y. So here is our y-intercept. So let's try one. It says find the x and y intercepts, then graph the equation. So the first thing you do is you create an XY table. We're going to find the x-intercept by putting a 0 into the y spot, and then we're going to find the y-intercept by putting a 0 into the x spot. So let's start with the x-intercept. We put the 0 in our equation into the y spot. That gives me 4x equals -3. I divide by 4 and I get x equals -3/4. So yes, your intercepts can be a fraction. The y-intercept, I'm going to put the 0 in the x spot, so that would be 4 times 0 minus y equals -3, or y equals -3. Divide by -1 to get y, and I get y equals +3. So I have two intercepts here. The x-intercept is the point -3/4, 0. So I'm going to go over here. This is kind of a little graph for this. It's almost to -1. And then my y-intercept is the point 0, 3, which is right here. Again, using a ruler, I can connect those 2 points, and you will see, obviously with 2 points, that it makes a straight line, and that I have right here is my x-intercept right there, and right here is my y-intercept. Let's try the next one. It says find the intercepts and graph the two equations on the same coordinate plane. The first one is y equals 2. So when I go to do my xy table, I have no choices here. I have to make y 2. So I put a 2 and a 2. I can put anything I want for x, because you notice in my equation there is no x. It got multiplied by 0 and disappeared. So I'm going to put a 0 and a 2 in. Doesn't matter. When I plot those points, 0, 2, and 2, 2, and I connect them without a ruler, I probably should have used a ruler, you can see that what I have here is a horizontal line. Now let's talk about the intercepts for a second. I actually do have a y-intercept. That's this point right here. That's my y-intercept, where x is 0. What I don't have is an x-intercept. I'm not allowed to put a 0 in for the y to find the x-intercept. Not allowed to do that. And my graph doesn't cross my x-axis anyway. It's parallel to it because it's a horizontal line. So let's look at the next one. X equals -3. So when you do your xy table, you have no options. X has to be -3. The equation says so. Y can be whatever you want. I always pick 0 and 2. It's just easy. I'm allowed to pick whatever I want because the y isn't there anyway, so it's going to get multiplied by 0 and disappear. So now when I plot those points, -3, 0 and -3, 2, and I connect them, you can see that what I have here is a vertical line. Do I have an x-intercept? Yes, I do. Right there is my x-intercept. I definitely have one, and you can see it in my table. It's where y is 0. Do I have a y-intercept? No, that line doesn't intersect the y-axis because it's parallel. So there's no, this one has no y-intercept This one had no x-intercept. All right, let's look at the next one. Find the intercepts and graph, and our equation is x plus 2y equals 0. So again, we're going to create an xy table. I want to find the x-intercept by putting a 0 in for y, and I want to find the y-intercept by putting a 0 in for x. So let's do the x-intercept first. I go to my equation, I put a 0 into the y spot, and I get x equals 0. So now I'm thinking, is it really necessary to put the 0 into the x spot, because I can already see I'm going to get a 0 for y? Well, I can go ahead and plot that point. That point just happens to be, the same point is both the x-intercept and the y-intercept. But can I graph my line? And the answer to that is no. I can't graph that line because I don't know if it goes this way. I don't know if it goes this way. I don't know how that line goes. So what I'm going to have to do is I'm going to have to pick another point to graph that's not an intercept. So I'm going to pick a point for y. The reason that I did that is because when one of your variables has a 1 in front of it, it's always easier to pick for the other one as far as arithmetic goes. So that would be x plus 2 times 1 equals 0. X plus 2 equals 0. I subtract the 2, and I get x equals negative 2. So that gives me the point negative 2, 1, and I can now see that my line is traveling this way through the origin. I kind of missed there a little bit. Down through the origin, but I wouldn't have known that had I not picked this third point. And remember, that third point is not an intercept. All intercepts have a 0 in them. If you look back on the page, all of the intercepts have a 0. All right, so let's do some conclusions that we have here at the top of the page. It says the graph of the equation y equals n. If you go back to example 2a, you will see that that is, and I'm going to write the word always, always a horizontal line. The graph of the equation x equals n is always a vertical line. And I don't know if you noticed this, but in example C, our equation was x plus 2y equals 0. That 0 right there, it is an equation like ax plus by equals 0. What that means, it will always pass through the origin. So when you have an equation that is equal to 0, if it's a linear equation in two variables, first degree, then you will always see that that equation, when graphed, passes through the origin.